Hey everyone, and welcome back for another deep dive.
Yeah.
Today we're looking at some research and ideas that are really going to challenge us to think differently about the universe.
Ooh, that sounds exciting.
We're talking about emergent spacetime, the idea that space and time might not be fundamental after all, but emerge from something even deeper.
Whoa. Okay, so it's kind of like questioning the stage itself on which the play of the universe is happening, not just, the actors in the story.
Yeah, exactly. And one of the most interesting models we're going to explore today is something called the dot model.
Dot model.
Yeah.
Okay.
So in this model, space-time isn't this fixed grid that we usually imagine, but it actually emerges from the relationships between these tiny, constantly interacting dots.
Okay, so instead of these like building blocks of the universe, it's more like relationships are the building blocks.
Yeah, you could think of it that way. And one of the sources we're looking at, emergent spacetime, a relational dot model, emphasizes that these dots don't exist in some kind of absolute space.
Yeah.
They actually only exist in relation to each other.
Right. So it's not that these dots are sitting in space, it's that their connections are what create the very fabric of space and time.
Exactly. It's like a constantly shifting network of relationships. And it's those relationships that define distances and time intervals.
That's a really interesting way to think about it. It's like how in a social network, right, it's not about where people are on a map.
Right.
It's about the connections between them.
Exactly. And that leads us to a really important concept called no absolute spacetime.
No absolute space-time.
Yeah.
Okay.
So in this model, the distance between two dots isn't some fixed number. It's actually more about the strength and history of their interaction.
So like the more these dots have interacted in the past, the closer they appear to be.
Yeah, you could think of it that way. And even time itself becomes kind of a measure of how intensely those dots are interacting.
So basically the whole universe is like one giant interconnected web where space and time are constantly being woven and rewoven by these tiny dots.
That's a great way to visualize it, but we got to add another layer here. Okay, hit me.
Another source, emergent spacetime. Coherence information and dynamic graphs introduces this concept of coherence.
Coherence.
Yeah, and it's super important for understanding how this whole dot-based universe actually works.
Okay, so what is coherence exactly?
Well, you can think of it as like the organizing principle of the system. It refers to the stability and the order that emerges from, all those crazy interactions between the dots.
Okay, so higher coherence means a more stable structure. Lower coherence is more chaotic, kind of like the difference between, a well-organized library and a room full of scattered papers.
That's a great analogy. So coherence is kind of like the cosmic glue that holds everything together.
I like that. Yeah, it's like the underlying harmony that determines how information is encoded and preserved within this network of dots.
Fascinating. So areas of this mesh with high coherence would be like really stable and packed with information.
Exactly. And areas with low coherence would be more chaotic, less information dense. So following that logic, black holes being the most information dense objects we know of, they would have incredibly high coherence, right?
That's a really sharp observation, and it brings us to another fascinating concept, spin.
Spin.
Yeah, the source information spin and a coherent model of reality dives into this idea that spin, which, we usually think of as something that rotating objects have,
Right.
it might actually be an intrinsic property of the mesh itself.
Okay, so instead of things spinning in space,
Yeah.
it's like space itself has this spin built into it.
Yeah, that's the idea.
Whoa, that's a lot to take in.
It is, and the idea is that spin could be influencing how these dots transition between states and how they maintain that all-important coherence.
I see.
And here's where things get really interesting. The most information-dense objects to black holes also happen to exhibit maximal spin.
Okay, so there could be this deep connection between spin, information, and how space-time emerges. It's all starting to come together.
It is. It's like we're piecing together a giant cosmic puzzle.
And speaking of piecing things together, you know how you, the listener, pointed out that waves can't exist without some kind of underlying circular property.
Oh, yeah, that was a really insightful observation.
Well, the circular origin of waves, really digs into this, highlighting how circularity could be even more fundamental than we realize.
It's amazing to think that even at the quantum level, circularity pops up everywhere, from the orbits of electrons to the mathematical functions that describe them.
Yeah, it's almost like the universe has this inherent circularity built into its very fabric.
It does make you wonder, what's driving this pattern?
Right. So to recap, we've got these dots constantly interacting. creating this dynamic space-time mesh.
Okay.
We've got coherence acting as this organizing principle, spin potentially playing a key role, and this intriguing hint of circularity as like a foundational concept.
Yeah, we've covered a lot of ground already.
We have, but the big question is, where do we go from here?
Well, some physicists are starting to ask, could this be the foundation for a theory of everything?
A theory of everything.
Yeah, that's what the source fundamental mesh, potential theory of everything, explores, although it's still highly speculative at this point.
Okay, so it's a bold idea, but even if it doesn't turn out to be the ultimate answer,
Right.
it's clear that this dot model is pushing us to rethink some pretty fundamental assumptions about the universe.
Absolutely. Like, what if gravity isn't just about mass bending space, but about information coherence density shaping reality itself?
Whoa.
Right? And what if space-time isn't the fundamental stage, but just an expression of something deeper? This interplay of information and coherence in this, cosmic dance.
Okay, my brain is officially melting, but this is so fascinating.
It is. It's really mind-bending stuff. And in the next part of our deep dive, we're going to explore the mathematical models that are being developed to describe this dot-based universe and what it might mean for our understanding of everything from black holes to the very nature of time itself. So stay tuned.
Definitely stay tuned. This is just the beginning, folks.
Oh. Welcome back to our exploration of emergent spacetime. Last time we were diving into this idea that reality might be this dynamic mesh built from information.
Yeah, it's definitely a lot to take in, but I'm really curious about, how we go from these abstract concepts to actual mathematical models.
Right. Can we actually describe this dot-based universe with math?
Yeah, is that even possible?
It's a challenge for sure, but that's what makes it so exciting. The source, Mathematical Models of Emergent Spacetime, outlines some approaches researchers are taking.
Okay.
And one of the key ideas is to use graph theory.
Graph theory.
Yeah. So instead of picturing spacetime as this smooth, continuous fabric,
Okay.
we represent it as a network of nodes and edges, kind of like a dynamic evolving graph.
Okay, so instead of like a smooth sheet, we're imagining something more like a web.
Right.
Where each intersection point is one of those fundamental dots.
Exactly. Each node represents a fundamental information event.
Okay.
The connections between them represent interactions. And here's the really mind-bending part. The distance between these nodes isn't fixed.
Okay.
It's determined by the information density and coherence between them.
So space-time literally warps and curves based on the information content of the mesh.
Right. It's like saying that information itself has this kind of weight that shapes the fabric of reality.
That's a really cool way to think about it.
Yeah.
And this actually aligns with Einstein's theory of general relativity.
Oh, how so?
Well, remember how in general relativity, gravity is described as the curvature of space-time caused by mass and energy.
Right, right.
So in this dot model, it's not just mass and energy that are warping space-time, but it's also the information content, the coherence density that's playing a role.
Wow. So this model could actually help bridge the gap between general relativity, which works great on like the large scale, planets, stars, galaxies,
right,
and quantum mechanics, which governs the microscopic world.
Exactly. Because in quantum mechanics, information is also super important.
It is. It's at the heart of it all. And the source, information spin, and a coherent model of reality suggests that spin could be the key to unifying those two.
Okay, hold on. Let's back up a bit. You know how we were talking about spin being intrinsic to the mesh itself?
Yeah.
Well, some physicists believe that this intrinsic spin could actually influence how information is encoded in the mesh and how those dots transition between states.
Right. So it's like spin is this hidden code that's governing how information shapes reality.
Exactly. But if that's true, shouldn't there be some way to actually measure this effect, like experimentally?
Well, there might be. The model predicts that a fast-spinning object should exhibit measurable gravitational effects that go beyond what classical physics predicts.
So, like, imagine a spinning top subtly warping the space around it more than we'd expect just based on its mass.
Exactly.
So we could actually test this idea by, like, measuring the weight of a super fast spinning gyroscope.
That's one possibility. There are other potential tests, too, like frame-dragging simulations, which explore how rotating objects distort spacetime. And if this model is right, we might see deviations from the standard predictions, all thanks to this relationship between spin and information stability.
That is so wild.
Yeah.
Okay, so we've talked about gravity. What about black holes? They're still one of the biggest mysteries in physics. Does this dot model offer any new insights there?
It might. The source, geometric singularity mesh, foundation of reality, suggests that black holes could actually be thought of as collectives of dots.
Collectives of dots.
Yeah, where information isn't lost, but rather encoded in the fundamental structure of the mesh.
Okay, so it's not that the information disappears.
Right.
It's more like it's woven into the mesh itself.
Exactly. It's kind of like when a file seems to disappear from your computer.
Right.
The information might still be there at the level of bits on the hard drive.
Okay, so even though we might not be able to access the information that falls into a black hole,
Right.
it's not really gone from the universe.
Exactly. It's still there in the fabric of the mesh.
Yeah.
And this idea pops up again in the informational mesh: spin, circularity, and cosmic coherence. This source takes it even further, suggesting that spin might not only be key to understanding black holes, but also dark matter and dark energy.
Wait, hold on. Dark matter and dark energy, those are like the biggest unknowns in cosmology. How could spin possibly explain those?
I know, it's a pretty wild idea.
It is.
But here's the basic idea: dark matter, which we can't see directly, but we know it's there because of its gravitational effects.
Right.
It might actually be regions of the mesh with very low coherence.
Okay.
So these regions wouldn't interact much with the regular matter that we see,
Right.
but they would still exert a gravitational influence.
So dark matter is like the invisible scaffolding of the cosmic mesh, subtly influencing everything but remaining hidden from our view.
I love that analogy. That's a great way to picture it. And then there's dark energy.
Right, the mysterious force that's accelerating the expansion of the universe.
Exactly. And some physicists believe that dark energy could be related to the inherent dynamism of the mesh itself, to the constant fluctuations and interactions between those fundamental dots.
Okay, so let me see if I've got this straight. We've got this model where space-time emerges from a dynamic mesh of information dots.
Right.
Coherence, spin, and circularity all play key roles in shaping this mesh and governing how information flows.
Yeah.
And it might even give us insights into black holes, dark matter, and dark energy.
It's a lot to take in, I know.
It is. It's like this whole new way of looking at the universe.
It is. And it's still early days.
Yeah.
We need to develop a more robust mathematical framework and figure out how to test these predictions experimentally.
Right.
But even if this model doesn't turn out to be like the ultimate answer,
Yeah.
it's pushing us to rethink some of our most fundamental assumptions about reality.
Exactly. It's opening our minds to the possibility that space and time aren't these fixed absolute entities we thought they were,
Right.
but rather emergent properties of something deeper, something more dynamic and interconnected.
I like that. And speaking of deeper and interconnected, in the final part of our deep dive, we're going to explore what this model has to say about time itself.
Well, that's going to be good.
It is so. Stay with us.
All right, so we're back for the final part of our deep dive into emergent spacetime. And, we've really been exploring this wild idea that reality might be this like constantly shifting mesh of information, and that even space and time aren't as fundamental as we thought.
Yeah, it's a pretty huge shift in perspective, realizing that those, basic building blocks of our universe might actually be more about relationships and information, and about like physical stuff.
Exactly. And in this final part, I really want to dig into what this model has to say about time. It's something we all experience, but it gets so weird when you start to really think about it.
It does. And, one of the things that this dot model suggests is that time isn't this fixed universal metronome, just ticking away at a constant rate.
Right. It's not like this absolute clock that's the same for everyone everywhere.
Yeah, exactly. Remember how we were talking about time being a measure of like interaction density?
Right. So more interactions between those fundamental dots mean a different experience of time.
Yeah, exactly. So that means that time is actually much more fluid and dynamic than we usually think of it.
So it's not just that gravity warps space,
Right.
but it's also affecting the flow of time by influencing those interactions and the information density.
Yeah, it's like time becomes almost like a localized phenomenon, not this universal constant ticking away in the background.
That's a pretty profound concept to wrap your head around. And emergence, dynamics, and the non-repeating universe suggest that in a universe where space-time is emergent,
Okay.
time is not only relative, but also irreversible. It brings to mind that old saying, you can't step into the same river twice.
It's a great analogy. The river, like time in this model, is constantly flowing and changing. The mesh is evolving. Those dots are interacting and creating new information. And this means that, no state of the universe, no configuration of the mesh can ever be exactly repeated.
So no going back in time.
Right.
No cosmic rewind button.
Not according to this model. The universe is constantly generating new information, new configurations, and that forward momentum, that's what drives the arrow of time.
That makes me think about entropy. the tendency of systems to move towards disorder.
Okay.
Is there a connection between entropy and this like arrow of time in the dot model?
It's a great question, and mathematical models of emergent spacetime actually goes into this. It seems like the universe kind of evolves in a way that maximizes entropy while still like adhering to the constraints of coherence, you know?
Yeah.
It's like this dance between order and disorder,
Right.
where information creation and the arrow of time emerge from that interplay.
So time in this model isn't just a measure of change, but
Yeah.
also a reflection of like the universe's drive toward greater complexity and, information content.
Yeah, it's like time itself is woven into the very fabric of information.
That's a really cool way to think about it. It challenges us to kind of rethink our relationship with time, you know?
And
What if instead of seeing time as something external to us, something we're trapped in, we see it as like this integral part of the universe's unfolding story, a story that we are actively participating in as information processing beings?
exactly. It's like we're not just passengers on this river of time, we're part of the river itself.
And that brings us back to like the core concept of this whole deep dive.
Yeah.
The idea that reality might be fundamentally informational.
Right. So space-time, matter, energy, all emergent properties of this underlying mesh of information.
So instead of asking, what is the universe made of, maybe we should be asking, what is the universe saying? What information is it encoding and processing?
Whoa, that's a really cool way to frame it. It opens up so many new questions, like if information is truly the fundamental stuff of reality, then understanding how it's structured, how it's processed, how it's transmitted could be the key to unlocking, the deepest mysteries of the universe.
And, this dot model, this idea of emergent spacetime, it's not just some wild theoretical idea. It's like a potential paradigm shift, a whole new way of looking at everything.
It is, and even if it doesn't end up being the, ultimate theory of everything, it's pushing us to think beyond our current understanding and consider possibilities that we just never imagined before.
Well, we've certainly covered a lot of ground in this deep dive into emergent spacetime, exploring how space and time might actually just be, expressions of this deeper informational reality. We've looked at coherence, spin, and circularity, and we even contemplated the very nature of time itself.
Yeah, it's been quite a journey, and, like any good exploration, we probably raised more questions than we've answered.
That's true.
But that's the beauty of science. It's a never-ending quest for understanding.
Exactly. So we encourage you to check out the sources that we talked about, dig deeper into those ideas that really caught your attention, and just keep asking those big questions about the nature of reality.
Because the universe is an open book, and we're all invited to read its pages and try to decipher its secrets. Who knows what incredible discoveries are waiting for us just beyond the horizon of our current understanding.
Keep exploring, keep questioning, and keep that cosmic curiosity alive until next time.